All right, today we're going to do topic 17, lesson 1, step up to 6th grade, understanding integers. And you already actually do use integers when you're doing measuring temperature. So we're going to start off with measuring temperature. Lila and Eric recorded these temperatures during an experiment: 10 degrees Celsius, 4 degrees Celsius, 0 degrees Celsius, negative 4 degrees Celsius, and negative 10 degrees Celsius. Make a mark on the thermometer at each of those temperatures. Tell how you decided where to place each mark. Solve the problem any way you choose. I can recognize positive numbers and their opposites. So opposite would be the opposite distance from 0. So let's get some things recorded here. So we'll start out with, get a good color here, blue. 10 degrees Celsius, and we want to take a look at how the thermometer is measuring. What are the intervals? So we can see we've got 0 and a 5 marked. So the longer lines will be counting by 5s, the shorter lines. So the shorter lines will be 1, 2, 3, 4, and so on, counting by 1s. And if you notice, I filled in the thermometer here so we could take a better look at it. And 0, everything above 0 is what we call positive, and everything below 0 is what we call negative. And negative is just a distance from 0. So negative 5 degrees is 5 points below 0. Negative 10 degrees is 10 points below 0, or degrees, and so on. So let's take a look and get some things on our chart here, or our thermometer. 10 degrees Celsius, here's our 10 degrees Celsius. 4 degrees Celsius, right under the 5. 0 degrees Celsius, right at the 0. Negative 4 is 4 away from 0. It's negative 4 is actually larger than negative 5, and that is a shift for some kids. So if you say negative 4 is greater than negative 5, we say 5 is greater than 4, but remember, negative 5 is 5 steps smaller than 0, and negative 4 is only 4 steps smaller than 0. So be careful of that. That's a common error. And that's how we make our marks on a thermometer. And so that's starting with some information that might be familiar to you. Now let's move on. So what are different ways to represent integers? So numbers that are negative and positive altogether, we call them integers. Um, Integers are negative or positive values. You can compare integers or numbers to degrees of temperature measured on a thermometer. When the temperature goes below 0, it is written with a negative sign. It's less than 0, kind of like on a number line, which you can see a little bit below here. We have a number line down here. So anything below 0 has a negative. Above 0, you could write positive, but you don't have to. You can just leave the number as a whole number without the positive sign. It's understood to be there. 6 degrees Celsius is 6 degrees warmer than 0. Negative 6 degrees is 6 degrees colder than 0. The distance from 0 is the same. They're both 6 units away from 0, and you can see they've kind of drawn that in there. Integers are the set of numbers that include the counting numbers and their opposites and 0. So all values, including the counting numbers, we call the counting numbers are the positive numbers. They're the numbers you've used since kindergarten. Integers are the negative, the opposites are the negative numbers, and all together they're called integers. And 0 is kind of tricky. 0 is not positive and it's not negative, but it is called an integer. The opposite of a number is the number itself. So let's check that. So, and this is kind of tricky. For example, the opposite of the number 3 is going to be negative 3. The opposite of negative 3 is positive 3. So when you say the opposite of the opposite is the number itself. So here's the number, here's the opposite. The opposite of that, we're going back to the original number. So the opposite of the opposite is itself. What is the value of, so negative, -9. So that is looking at the opposite of the opposite. So the value of negative -9 is 9. Then you can look at this. Remember, when we have the negative sign outside of parentheses, it's inferred to be 1. So -1 times -9 equals +9. The rule for integers is a negative times a negative equals a positive. A negative times a positive equals a negative, and a positive times a positive equals a positive. So those are some rules that will help you in first in math as well when you're doing integers. So a negative times a negative equals a positive. A negative times a positive equals a negative. So let's move on. Which is warmer, 2 degrees Celsius or -5? And don't get tricked, because we all know the number, the integer 5 has a larger value than the integer 2. But remember, -5 is less than 0. So make sure you're remembering that. So 2 degrees Celsius is warmer because 2 degrees Celsius is greater than 0. 2 degrees Celsius is greater than 0. Whoops, make that a little bit bigger. And -5 is less than 0. And you can write that out in words too. Which integers do you use for counting? And for the counting numbers, we use what we call the positive integers. Positive integers. So who knew when you were in kindergarten that you were learning that when we were saying the counting numbers, what you were really doing was using the positive integers. We just didn't want to confuse you too much. How would you read this value here? -30. When you see that dash, you call it negative. And then you just say the number, whatever's after it. In 4 through 9, use the number line below, give the integer that each point represents, then write its opposite and tell how many units the number is from 0. So we have 3 things we need to do. We need to give the integer, write its opposite, and tell how many units it is from the number 0. So looking at A, we're going to say A's value is -7. Remember 0, 1, 2, 3, 4, 5, 6, 7. -7. So the value is -7. The opposite of -7 is +7, and you don't have to put the plus sign. And it is 7 units away from 0. For B, over here, our value is +4. The opposite is -4, and it's 4 units away from 0. For C, the value is 0, the opposite is 0, and it's 0 units away from 0. For D, our value is -2, the opposite is +2, and it's 2 units away from 0. For E, our value is +2, the opposite's -2, and it's 2 units away from 0. And for F, the value is -5, the opposite's +5, and it's 5 units away from 0. Whenever you're doing the units, it's always going to be a positive number, because we're just asking how many steps is it away from 0. It doesn't matter in which direction. Moving on to the independent practice. Write the opposite of each integer and tell how many units the number is from 0. So this is the work you're going to do on your own. And we're also going to work on some of the math practice and problem solving. So Ella picked the polygon with the greatest perimeter. Which of the following polygons did she pick? And remember, perimeter equals the sum of all sides. And we've got different polygons here. Doesn't matter. We have squares, rectangles, and equilateral triangle there. equilateral acute triangle. So if we added all this, the perimeter for A would be 8 plus 8 plus 8 is 24 centimeters. The perimeter for B would be 5 plus 5 plus 5 plus 5 is 20 centimeters. The perimeter for C, 7 plus 7 is 14, and 4 plus 4 is 8. So the perimeter is 22 centimeters. And for letter D, 6 plus 6 is 12, 5 plus 5 is 10, 22 centimeters. So the largest, the greatest perimeter is going to be A on that one. Sam said that any integer in the same distance from 0 is the opposite of its opposite. Is Sam correct? Yes, that's true. And explain the reasoning. The opposite of the opposite of the opposite is the number itself. And you can think, if I say yes, the opposite is no. What is the opposite of the opposite? It's yes. So it's the same thing. And 28, what could the number negative 18 represent? Well, it could represent a lot of things. And what would its opposite represent? What would 0 represent? So negative 18 could be maybe you owe your brother $18. So that would be considered a negative 18. And the opposite of that would be positive 18. And what would 0 represent? 0 would be you owe them no money. You owe them nothing. So we do use integers all the time. You use subtraction values all the time. A dolphin jumps 3 feet above sea level to go through a ring. The dolphin starts at the opposite distance below sea level. How far does the dolphin travel from its starting point to the top of the jump? The dolphin can swim to 150 feet below sea level. So he jumps 3. Here's sea level. You can draw a picture. He's going to jump 3 feet, and he jumped 3 feet to go through a ring, and he starts at the opposite distance below sea level. So he's starting 3 feet below sea level. So he's actually starting down here and going all the way up here. So he would be 3 feet plus 3 feet. So altogether, he would travel 6 feet. And how do you know? We can show from our diagram, from 3 feet to 0, from negative 3 feet, so that's below sea level. From negative 3 feet to 0 is 3 feet, and then from 0 to 3 feet is 3 feet. So altogether it's 6. So negative 3 plus 3 for distance. So what we want is called the absolute value, is going to be a distance of 6 feet. Choose all the equations that are true. Negative 5 does not equal 5. The opposite of 9 equals negative 9. That one's true. The opposite of negative 2 is positive 2. So that one's true. Negative 3 equals the opposite of negative 3. So that would be equals 3. So that is not true. And the negative, as you've got to go from the inside out here. So negative 6, the opposite of negative 6 is 6. And then negative 6 is on the outside equals 6. And that is not true. And number 31, choose all the statements that are true. 3 steps backwards is written as negative 3. Good. 12 feet above sea level is written as negative 12. No, that would be 12 feet below sea level. Lee owes Katie $5, so Katie has negative $5. No, that's just Lee owes her $5. And Thomas owes Joey $6, so Thomas has negative 6. Yeah, he's the one that owes. In this case, Katie doesn't owe, Lee owes. 356 feet below sea level is written as negative 356, and that's correct. There you go.